Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day, and in this video I will give you an approach that will solve in the big O of one time complexity and big O of one space complexity. Now let's start the video. So problem is reverse the bits. This is LeetCode 190. Video process will go this way. First I will explain the question, then approach, then code explanations, optimize the approach and optimize code versions, and finally complexity analysis. Now coming to the question part, question is fairly simple. This is an easy question tagged by LeetCode. So how it's easy I will explain, how it's difficult I will explain. Question is reverse the bits in a given 32 bit signed integer. So that means there are 32 bits over there and you have to just reverse it. So let's take an 8 bits integer and now reverse it the bits. That means you just reverse this position to these positions. That means it will be 0 1 1 0 1 1 0 1. This is the reverse of this binary representations, and it is 8 bit but we have to do in the 32 bits operations. So one thing you can do, you can swap these two positions for reversals, swap these two positions, swap these, and this will give you these answers. Now come into the approach part. First of all, I think you get the approach correctly. Like, let's take the indexing part. So it will be 0 1 2 3 4 5 6 and 7. So swap 0 and 7, swap 1 and 6, and 2 and this 2 and 5, and 3 and 4. So actually these two things swap these two and these two. If you swap these positions, then it will be actually the reversal. That means it will give you the 1 1 0 0 1 1 0 1. This will give you the reversals of these binary representations. So we just try to iterate from over here to here, half of the bit size, and we just reverse the bits according to the positions. So first of all we iterate through the first 16 bit. Why? This is 32 bits given, so we just go 0 to 15, that means 16 bits, and also calculate the mirror positions. That means when we are in these positions, that means at the 0th we just want to mirror position. That's, you can consider this is a mirror. We just swap according to this mirror. So we just take this position, that is 7, that is j equal to 31 minus I. This will give you the mirror positions of that particular ith positions bit. And we just check if it is mismatch, because if, let's say 4 bits number, this was a 4 bits, so we just want to swap these two positions, but this is 1 and this is 1. Does we need to change any operations? No, we do not need to change any operation. But if you consider these two bits, that is 1 and 0, this is at the different, so we have need to change these operations. In the 1 positions it will go to the 0, and in the 0th position it will go to the 1. So it will be this way. This is the answer. So we just need to check if ith positions and jth positions mismatch the bit, then we can just flip it using the XOR operations. I will show you can do that thing, and at last they return the answer. Now come into the coding part. Okay, so first of all complexity, you can say we are iterating through the 16 bit, so big O of 16, and you can consider this is as big O of one time complexity, and for the space complexity we are using constant space, so it will be big O of 1, and also we are try to do in the in place algorithm. Now coming to the coding part, I will explain the code in the C++, but Java and Python versions is exactly similar, and you can find it in the descriptions. So first of all let's define long. Why? Because we just want to shift it, so take it long just to avoid the overflow, although it will not be overflow because 32 bits is represented under the integer. So int reversal, that takes number int n, and we iterate through the half of the bits to swap the other half. That means I equal to 0 to 15, and we just calculate j equal to 31 minus I. This will be the mirror positions. And now try to calculate the lower bit and upper bit. How we can do that? So we try to do, we just take the number n and shift left to the ith positions and ampersand with 1. That means let's take an example. 1 1 0 1, and if we try to shift, we want to know these positions whether it is 1 or not. So we just left shift the two positions, that means it will give you the 0 0 1 1. This will go to the left shift, that means this bit will come over here. And if we try to AND with 1, that means all 0 and AND with 1, if it is in this position, if it is 1, then it will give you 1, otherwise if it is 0, this will give you 0. So according to that, we just calculate the lower bit and upper bit. Now we just check whether lower bit not equal to upper bit, that means there are mismatch. So we just need to flip that bit, that means n XOR equal to 1 at that position. This means let's say we have 1 1 0 1 and we just want to flip this bit. So first of all we 1 over here and we just right shift to up to the jth positions, that means these positions. So it will be 1 1 0 1 and 1 0 0, these positions. And when you XOR with these two numbers, if it is different then it will give you 1, if it is same it will give you 0, it will same 0 and different 1. Now you can check that this bit is already flipped and other are remaining same. So this way similarly for the jth versions also do the same things to flip the bits and at last just return the answers. So it will be the fairly simple approach. Now come into the little bit complex, and it is used for fast Fourier transform. So before going into that part, you can support my work via like and subscribe the channel, comment the understood and upvote in the LeetCode solution post. Come into the optimized approach part. So instead of taking the 32 bits integer, just we can take the 8 bits integers and we try to dry run what we want to do. So it taken 1 0 1 1 0 0 1 1. So this is number, let's n equal to given over here. This is the binary representations. Now what we want to do, first of all we just split in half of the bits and try to swap it. That means half means 4 bit. So we just these bits swap to the next positions. That means we just swap these two bits, these two portions, 4 bits in swap space. That means 0 0 1 1 and it will swap with 1 0 1 1. Now for each of these two we just again try to recursively try to do same things like split in two halves and swap it. So it will be 1 1 0 0, and similarly if you do these operations over here it will give you 1 1 1 1 1 0. Now try to do this same thing for one bit. So we will take this and these two are things. So it will, let's swap these 1 bit positions, it will give you 1 1 and this will also give you, swap these two, it will give you also 0 0. Now swap this one, it will give you 1 1 and swap these two, it will give you 0 1. And if you try to do write in same, if you try to write in continuous way, then this will be the reversals of this number. So you can check it 1 1 0 0 and 1 1 0 1. Yeah, that is the exactly reverse of these things. So there are simple things like fast we what we want, fast half the bits, and second is swap them. But how you can swap it? Now let's try to dry run examples. Take the same example over here, 1 0 1 1 0 0 1 1. Now what you can do, first you want to take this much portions, and you can try to left shift up to the 4th positions. That means first take these positions, so try to do these things so that we get that exactly these positions. You can AND operations, so it will give you 1 0 1 1 0 0 0 0. This is first number, let's take an A1, and another number is this way 0 0 1 1. We just want to take this much portions, that you can say 0 0 0 0 over here and 1 1 1 1, and AND operation, it will give you all 0 0 0 and over here it's 0 0 1 1. So you get this number. Now let's consider it's B1, and if you try to do these things, first of all A1 left shift of 4, that means this much portions go to the this place. It will give you first of all 0 0 0 and 0, then 1 0 1 1, these numbers when we left shift up to fourth positions. Now it will be right shift up to fourth positions, so that will give you 0 0 1 1 and again at last 0. Now try to do the OR. So if you OR these two numbers, it will give you 0 0 1 1, it will give you 1 and 0 1 1. Okay, now fourth 4-bit positions is done. Now try to do the 2 bits. So first of all you get the number by this way, 1 1 0 0 1 1 0 0. This way you get one number that you can consider A2. Another number is 0 0 1 1 1 0 1 1, and another number you can get is 0 0 1 1 0 0 1 1. That means we just want to swap these two numbers, like two numbers. This will be in chunk of 2. So if you try to do the AND operations, it will give you 0 0 0 0 over here also, and I think it's 1, yeah. So it will give you 1 0 0 0. This will give you the A2, and if you do these things it will give you the B2. That means it's also an AND operations, 0 0 1 1 0 0 1 1. This will give you the B2. Now A2 and B2 XOR with these two or with these two numbers, that will give you 0 0 0 0 1 0 0 0 and 0 0 1 1 0 0 1 1. Now or these two numbers, it will give you 0 0 1 1 1 0 1 1. Now these are the, if you want to check these two things, that means it will be swapped for two numbers. Okay, and similarly you can get at the last one you get A3 via 1 0 1 0 1 0 1 0 1 2 3 4 5 6 7 8, and B3 via AND operation with 0 1 0 1 0 1 and 0 1 1 2 3 4 5 6 7 8, this way. And when you do this A3 OR operations with B3, this is B3, then you get the exact reversals, and this way you get the answers, the whole reversals. You can consider it's an recursive approach, but although we have only the 32 bits, so we can do this way. I will show you in the code. First of all we can swap 16 bit, then 8 bits, then 4 bits, 2 and 1. At the last we just return the answers. First of all, how we can do these things, they're same as I already described. So 16 bits 1, then 16 bit 0, and left shift with 16 positions. Similarly 16 bits 0 and 16 bit 1 and right shift to the 16 positions. No, sorry, it will be right shift and it is left shift to the 16 positions. And when you get this, it will be swapped for the 16 bit. Let's say this is the first 16 bits and the second 16 bits. When you does these operations, it will go to these 16 bits over here and these 16 bits over here. Once it's done, then it will split each of them half and again swap it via 8 bits operations. So far 8 bits 1, 8 bits 0, 8 bits 1 and 8 bits 0. Similarly first 8 bits 0, then 8 bits 1, 8 bits 0 and 8 bits 1. Similarly for fourth case, that means 4 chunks, that starting from first 4 bits 1, then second 4 bits 0 and continuously. And similarly for 2 bits 0, 2 bits 1, over here 2 bits 0, then 2 bits 1, and for last one is 1 bit 1 and 1 bit 0, and over here 1 bit 0 and 1 bit 1, and at last we just return the answers. And in this way we can get the answers so quickly. That means this you can consider it's an big O of, we are not iterating any of these loops, so you can consider it's an big O of 1 time complexity. And for the space, we does not take any extra space, and it's an in place algorithm, so it will take big of 1 space complexity. So thank you guys, thank you for watching, stay tuned for more videos, and if you guys think it's helpful, please like and subscribe the channel.